Hi everyone. So our guiding question this week is, how does soil and land cover impact infiltration and runoff? This was the research that I had conducted about this with the different land covers and the different types of soil. Coming to the conclusion is that areas with the highest amount of vegetation, like your desert and your forest and your grasslands, with a group A soil is where you're going to have the lowest runoff rate and the highest amount of infiltration. I had highlighted group A of sand and developed low because that is the area that I'm in right now, which is Myrtle Beach. The standards that I had pulled was one for K to 2, and that is all about developing solutions to prevent wind or water from changing the shape of our land. And also I had found some for 4th grade with your PA environment and ecology standards that really focus on watersheds. This is my this is where I was starting to brainstorm about the idea of the erosion bottle and what materials I was going to use, and this is where I created my plan. So as you see, I have 3 different water bottles with 3 different types of sediments in each water bottle. So bottle 1 had soil and sand, bottle 2 had soil, sand, and mulch, and bottle 3 had soil, sand, and grass. Here are my bottles. Here's the top view, and here is from the side. And here is my video of me conducting the experiment. As you can see, there's a lot of soil that had run off in bottle number 2, which was extremely surprising to me after the research that I had conducted. So the results I found was that bottle 1 had the second most amount of sediment in the water that was left off, and in bottle number 2 it was the most amount, and there was a lot of mulch that was going into that was running off, and also a lot of soil and dirt. And then the last water bottle, the water was not clear, but there was clearly a less amount of soil that ended up into the cup. After the experiment, I realized that my experiment did not match my research. When I did the research, it said that your soil with your sand, and your sand is your highest grade, that is going to prevent the least amount of runoff, and it's going to soak up most of that water. So to improve this, I thought, well, maybe I did too much water too quickly. But then when I went down in the morning to check on the water bottles to redo the experiment, I noticed that the sand was now solid and hard. And I said, well, I'm going to redo the experiment, but keep the sand the way that it is right now. So I redid the experiment, and as you can see, I did have some different results. My water is more clear, and I think that's because over time, sand does become harder and harder underneath the ground. So the way that I had the sand before, very loose, was not a true representation of what sand is like in the environment over so much time with water running on top of it. So I think that because I had more solid sand, my results were more accurate this time and really did match my research. So when you are matching it with the STEM practices, in science we are asking questions and we're developing these models. We are answering about what is the best landscape, and then we design the model to match it. Same thing with the engineering, was designing the model to match the question. With technology, we had used a website to research and get some great background knowledge of the topic before we actually conducted the experiment. And with mathematics, we were making sense of problems and then persevering through them. And then we were also looking for and making use of a structure, which was the model that we also had used. Thank you all so much.